Hello and welcome back. This is the afternoon session of the Digital Memory seminar focusing on the applications of AI in the cultural heritage domain. We have 5 really exciting papers lined up for you for this afternoon. Each of them is discussing a different application area or a use case of AI in the cultural heritage domain. We're starting off with Eleftheria Tsoupra from Europeana Foundation, and she works at the R&D team there, and she's going to present their work on image analysis with the help of AI. Please.
Hi, I'm Eleftheria from Europeana Foundation, and during this video, I would like to present to you how the St. George on a Bike project has been using AI to enrich cultural images. So first, let's see some context about the project. St. George on a Bike started in September 2019, so 2 years ago, and it will be completed in about 10 months from now. The project is a collaboration between the Barcelona Supercomputing Center in Spain and Europeana Foundation in the Netherlands. And the aim of the project is to enrich metadata associated with images from European cultural heritage using AI-based content analysis and machine learning technologies. So what are the main goals of St. George on a Bike? First, we want to enhance the findability of cultural objects in platforms like Europeana, and we want to do this by providing a service for automatically enriching the metadata of images based on their visual content. It's worth saying that such a service could be easily integrated via its API to other platforms that could also benefit from using this service. And the St. George on a Bike project wants also to develop a prototype search service in order to showcase how the generated enrichments could be used further to improve also the searchability of objects. Another objective that the project has is to upload the generated enrichments as well as the training datasets to open data sharing platforms. Of course, the first scenario is to upload this data to Europeana, which has data sharing APIs, but we are also committed to upload this data to European Commission's portal called data.europa.eu, and also to establish the research platforms like the European Open Science Cloud and similar ones. In order to be able to generate these enrichments and to meet our goals, we need data. And for St. George on a Bike, data means images, especially paintings coming from the early 12th to the late 18th century. The two themes appearing in the majority of the paintings from this period are religious art and mythology, and one of the main characteristics of these paintings is that they are very rich in symbols. An example of such a painting can be seen on the right. The symbol in this case is the flower that the angel holds, which is a white lily. So as some of you may know, the white lily was adopted by the Roman Catholic Church as a symbol of Virgin Mary, which in this case helps us to identify the angel that is holding this lily as Saint Gabriel, and also the topic of the painting, which is the Annunciation. Of course, to be able to identify paintings with symbolic meaning and collections that include these paintings, the original metadata can be very useful when they exist. So, how do we exactly process these paintings in the St. George on a Bike project? The first step in our pipeline is object detection. So we've used an existing generic model as a starting point and retrained it with our own data, so with cultural heritage data. For this, we used 98 classes that represent the most common objects with iconographic and symbolic meaning that we could find in paintings from Wikimedia Commons, Wikipedia, Wikidata, Wikipedia, and Iconclass. So these classes represent supernatural beings like angels, dragons, gods, but they also represent animals that appear in cultural heritage paintings like lions, dragons, and also biblical and historical figures like Jesus Christ, Virgin Mary, Adam and Eve, and so on. So using this transfer learning approach, we are now able to detect objects that represent these classes in paintings. And we see an example of object detection applied using our model. On the right, as you can see, the model was able to detect two objects in this case and to generate labeled bounding box for each of these objects. Excuse me. So we have an angel and a person. And this sort of labeling of the objects is already a good step, as it can lead to associating semantic tags to the image. And by semantic tags, we preferably mean URIs coming from linked open data vocabularies like Wikidata or Iconclass or similar ones. However, semantic tags is not the only level of metadata output that the project wants to handle. Another possible level of metadata output could be captions, or otherwise short, simple, and concise descriptions of the visual relationships between the detected objects in an image. And we see such visual relationships in the painting on the right. So we have a visual relationship between the person and the horse. So the person is sitting on the horse, and another visual relationship between the person and the sword. So the person is holding a sword. So for generating captions that include such visual relationships, we have been experimenting with bounding box analysis and natural language processing techniques. So by analyzing the size, the position, and the possible overlap between bounding boxes, we are able to make predictions about visual relationships and to generate more context, more information about the detected objects. So for this particular painting, we could say that, for example, a person that is sitting on a horse is a rider, a very basic example. Of course, generating these captions is not as easy as generating labels, as you can imagine. So this is still in an experimentary stage, I would say. Moving on to the data sources here, you see some of the data sources that we used in order to create our data set for training and testing the model. Of course, Europeana is one of these data sources, having contributed so far more than 2,000 images, but we've also used images from the ICON class AI test set, from Wikimedia Commons, Prado Museum, Rijksmuseum, and many more. Currently, our dataset consists of about 13,000 images, and it's worth saying that these images have been manually annotated by the people working on the project. And the reason that we had to create these annotations manually is related to one of the challenges that we have been facing during the project, which is the availability of accurate and appropriate data for training. So what we found out is that the amount of appropriately annotated images is quite small, and these annotations are not always at the level of granularity that we target in the St. George on a Bike project. And even if annotated images are available, these do not target image regions, which means that we still need to create the bounding boxes on our own. And lastly, the descriptions of cultural objects, as many of you already know, do not usually focus only on the visual content of images, which means that to be able to reuse these descriptions, we need to pre-process them and filter out the information that's not related to the visual content. So in general, this means quite a lot of manual work. And at this point, it's also worth mentioning that we keep looking for more data for the project. So if you have interesting data for us, please don't hesitate to get in touch. Moving on to some more challenges, first related to copyright. So not all images that we wanted to use are open for use, which may create limitations. Another issue that we had is related to data flows. So we had some difficulties with tracking the provenance of collections that are aggregations of other collections, and perhaps a more serious issue that we had is related to link growth, which refers to the phenomenon of hypertext links tending over time to break, which of course may have a negative impact on the size and on the quality of the data set, especially towards the end of the project. Finally, another challenge that we see is related to the evaluation of automatic enrichments and how best to ensure their quality. So at the moment, we have been discussing several quality measures and assessment processes. One tool that could be used not only for evaluation purposes, but also, and perhaps more importantly, for sourcing more data for the project is crowdsourcing. And at the moment, the project is looking at organizing some crowdsourcing campaigns for this purpose. With crowdsourcing, we could get actually all different types of annotations that we need for the project. So from the most simple object labels to the most complex one, which is captions, including, of course, visual relationships. The problem with this is that in order to be able to get all these different types of annotations that we need for generating different levels of metadata output, we need to organize multiple campaigns with different requirements. And we know that some of these requirements, especially the requirements about creating captions, are quite hard to articulate. So one of the things that the project is going to investigate is how non-cultural experts can produce annotations with the same level of quality and focus as cultural experts. But in general, we believe that by combining the AI tools that we have with crowdsourcing, we can perhaps accelerate and improve the enrichment process. And that brings me to the end of this presentation. I hope this was enlightening. Thank you very much for your attention, and I'm happy to answer any questions you may have. Thank you.
Thank you. Perhaps I start off with a question that we asked already from the previous speaker. It's about the competencies and how this was realized as a project. Did you do everything yourself, in-house, as it were, or were you relying on an external technology provider or a solution provider for this?
Yeah, hi. Yeah, actually behind this is I mentioned this in the first slide of this presentation. It's the Barcelona Supercomputing Center in Spain.
So they are helping you with this work.
Yeah, with the infrastructure, basically. Yeah.
Okay. But the AI-related, the machine learning-related competencies, that's part of the R&D team at Europeana, or you're also relying on Barcelona Computing Center?
We are completely relying on the Barcelona Supercomputing Center.
Good. The fascinating thing was the relations between objects on the image and how do you capture that. And the even more interesting layer, I guess, is the dynamics of this relation. Is it about, is St. George slaying the dragon, or is it defending itself and his horse against a dragon that attacks them? That's always... there are ways of interpreting this, and a good example of a source, how bias or misinformation can come into the description here. Have you looked at not just the static relation, like the man holding a sword, but also the dynamics represented in the picture? Have you gone as far as that?
Yes, I mean, we are experimenting a lot with this at the moment, but I would say that this is also one of the most challenging things that the project has to work on. So to go beyond these visual relationships, at least the basic visual relationships that I presented. So we are working on this at the moment. And
So these captions that you are creating, where do you expect them to end up afterwards? Where will they live? Will they be part of the description of these objects in Europeana, or is there going to be a separate collection, machine-readable ontology of mythical creatures and art images? What's the end result?
Yeah, as I mentioned when I talked about the main goals of the project, so St. George on a Bike wants to develop a prototype search service. So one could search a collection using some of these visual relationships that I mentioned. So yeah, one of the outcomes would be to enable a user to search by those visual relationships in a collection. But this will be only a prototype service, and then we will see, of course, at Europeana how we could further develop this idea.
Sure, but when the user is conducting the search, is the image analysis happening on the fly in real time, or is it based on the captions, as you mentioned, that are created beforehand and recorded somewhere in a database and associated with the image?
No, yeah, it won't happen on the fly. It will be based on a list of visual relationships that we will have, hopefully, at the end of the project.
Okay. And crowdsourcing will be used as a way of not just validating, but also collecting extra information as an input. Did I understand that correctly?
Yes. Yes, actually, we want to use it in both ways. So both for sourcing more data, for training the model, but also for evaluating the automatic enrichments afterwards. So yeah, we believe there is a lot of potential with crowdsourcing, and yeah, the combination of crowdsourcing and the AI tools that we have developed. So
our previous speaker said that 10,000 books or texts is not really enough to train a machine learning algorithm to assign correct keywords or subject headings. What is your experience? Is roughly the same volume of images good enough sample to train your algorithm? Or you just said that you're looking for more information or more data? Do we have an estimate of how much is enough?
To be honest, I'm not sure. What will be the perfect amount, but I know, for example, that modern data sets like the SGoaB data set that includes images of present life objects is, I think, about 200,000 images, something like that. And at the moment we have about 14,000 images. So I mean, the more of the images you have, the best the performance of the model could be. And that's one of the main challenges, to be able to source this number of images. But I don't believe that we will arrive there. I mean, we are still having 10 months to complete the project.
So is there a way for the institutions that are listening to you now somehow participate in this crowdsourcing event or campaign that you are organizing? Is there a link?
Of course, but no, there is no link at the moment because we are still discussing and working on the requirements for those crowdsourcing campaigns. So I don't have any specific information at the moment, but once we have, we will try, of course, to promote those crowdsourcing events to the GLAM community.
Great. So everybody keep an eye on St. George on a Bike project, and you'll have a chance to submit your own descriptions as well as your images of fanciful art. Thank you.